Hello everyone, in this video I want to talk about transformations of logarithmic functions. Now, if you've been following my channel and watching my videos for any number of time, you've probably seen a couple of videos that look very similar to what's on the screen right now. And that's because these transformations are the same transformations we do for linear functions, absolute value functions, quadratic, exponential, so on and so forth, right? So they're very important to learn and to understand because you're going to continue to see them over and over and over again, as we've seen with the different videos I've made for the channel. So without further ado, here we go again, transformations, but now this time, a different type of function, logarithmic functions. So we have our transformations over on the left, our notation in the middle, and a couple examples on the right, and then we'll do two examples together at the end with graphing. So horizontal translation is when we're going to shift left or right. Just remember that h is our variable for that, and we start off with this negative sign or the subtraction sign initially. And so that's why when we look at our examples over here, it kind of looks a little bit opposite of what we would think. We see x minus 4, that's telling me to go right, and plus 7 is telling me to go left. Because if I were just to plug in 4, so if I said h is equal to 4, right? Well, when I plug that in here, it's going to look like x minus 4, right? Well, what h was actually positive, so that's why we're going to the right. Well, over here, if I'm going to the left and I said, hey, h is negative 7. Well, when I plug that in, I get x minus negative 7, which is why it becomes x plus 7, okay? So that's why it does look a little bit opposite there. Just remember that for horizontal. Vertical translation is when we shift up or down, and we use the variable k there. Notice how that it is not happening directly to x, it is happening to f of x, which is y. That's why it's a vertical movement. It is what it looks like. Plus means we go up, minus means we go down. Reflection, we could reflect over the x or the y-axis, and it's essentially like a flip. So if we're going to reflect over the y-axis, we're going to make x opposite, and if we're going to reflect over y, we're going to make if we're going to reflect over the x-axis, we're going to make f of x opposite, which is like making y opposite. Okay, so we see right here, negative x, reflect over the y-axis, making the entire thing negative would be reflecting in the x-axis. Horizontal shrink and horizontal stretch. We're going to stretch away from or towards the y-axis. We use the variable a here. We also use a for vertical, so notice the placement of a. For horizontal, it is inside with x, and for vertical, it is outside, happening to f of x, right? Vertical, f of x, output, up and down. Horizontal, input, x, side to side, left and right. Now, horizontal is a little bit opposite of what it looks like, just like horizontal translations, and that's because our factor is actually 1 over a. So if I'm looking at this example here where it says log base 3 of x or log of 3x, it's actually a shrink by a factor of 1/3. Why? Because what is a? Well, a is 3. So my factor would be 1 over 3, which is 1/3. Well, if I have 1/3, that's got to be a shrink. Okay. The next one is g of x equals log base 1 or log 1/3 x. And that's going to be a stretch by a factor of 3 because 1 over 1/3 would be 1 divided by 1/3. Well, that'd be 1 times 3. So we get 3, okay? And vertical stretch and shrink is what it looks like. We're going to stretch away from or shrink towards the x-axis. And that multiplication is going to be located outside of our log. So 4 times log of x is just going to be a stretch by a factor of 4. And 1/4 log of x is going to be a shrink by a factor of 1/4, okay? Like I've said, we've seen these transformations numerous times. We're now just applying them to logarithmic functions. So we're going to do two examples here. We're going to describe the transformation of f represented by g, and we're going to graph. So for a, we have f of x equals log of x, and g of x equals log of negative 2x. So if we think of log of x, that's like having a common log, right? Our base is 10. And so remember, to graph logs, we can graph our exponential function and just find the inverse, which would be our log function. So for y equals 10 to the x power, I know that anything to the 0 power is 1, so I'd have a point at 0, 1, and then 1, 10, right? And so my graph would look something like this for my exponential, because we know that it approaches that x-axis but does not cross it, okay? So now we'll do our log here in blue. So f of x equals log of x. And essentially, I'm going to take those 2 points that I graphed for y equals 10 to the x and just switch the x and y, because that would be how we find the inverse. So instead of 0, 1, we're going to have 1, 0. And instead of 1, 10, we're going to have 10, 1. Okay? And now our graph is going to look something like this. Okay, now our line here is going to approach the y-axis, not our line, but our curve, is going to approach the y-axis, but it's not going to cross it, okay? So now we don't need the red graph anymore. That just helped us to graph our log function. So now in green here, we'll graph our g of x function, which is negative 2x. So that negative 2 there's two things happening. Number one, we have a reflection. It's going to reflect over the y-axis because that negative is inside with x. And number two, we have a horizontal shrink by a factor of 1/2 because we see that 2 there being multiplied to x. So if I look at these 2 points that I have, we're going to decrease or shrink their x coordinates by a factor of 1/2. So this point that I have right here has an x coordinate of 1, so it's going to move to 1/2. And this point over here has an x coordinate of 10, so we're going to bump it back to 5. 1, 2, 3, 4, and 5. Now, before I draw my curve through those points, we have not reflected yet. So now we're going to take those 2 points and we're going to reflect them over the y-axis. So that would bring my point right here, instead of 0.50, it's at negative 0.50. And instead of having a point at 5, 1, we're going to have a point at negative 1, 2, 3, 4, 5, and 1. So now we can get rid of these 2 points because that kind of just helped us get to our final graph. Okay, so now we're going to draw our curve as best we can here, and we're still approaching that y-axis and not crossing it. Okay, so this would be our g of x function here, and we had our f of x function right over here. All right, so what are our transformations? We just mentioned those a second ago. We are going to reflect over the y-axis, and we are going to shrink horizontally by a factor of 1/2. Okay. All right, let's take a look at b. We have f of x equals log base 1/3 of x, and g of x equals 3 times log base 1/3 of x minus 2. So once again, we can use that same logic. We're going to graph y equals 1/3 to the x power, and that's going to be our inverse for our log function here. So 1/3 to the x, once again, anything to the 0 power is 1. Then we would have like 1/3 here, right, getting really small. Well, if x is negative 1, that's going to be 1, 2, 3, and negative 2 would be 4, 5, 6, 7, 8, and 9. So this would be my graph of my exponential, which would be y equals 1/3 to the x power. Okay, approaching that x-axis but not crossing it. All right, so now in blue, we will graph our f of x function, and that is basically just the inverse, or it is the inverse of what we just graphed in red right there. Okay, so if we think about our, let's just do these 3 points right here. Okay, so instead of 0, 1, we're going to have 1, 0. Instead of negative 1, 3, we're going to have 3, 1, 2, 3, negative 1. And instead of negative 2, 9, we're going to have 9, negative 2. 9, negative 2. Okay, so now let's take away what we have here so that we can see our graph really good. All right, so we draw our curve best we can through there, and we're looking like that for our f of x function. Now, in green, let's graph our g of x. So once again, we have 2 things happening. Number one, we are going to vertically stretch by a factor of 3. And number 2, we are going to translate right to units. Okay, so vertical stretch by a factor of 3. Let's adjust these 3 points that we have here, and we're going to multiply their y-coordinate by 3. Well, my first point right here has a y-coordinate of 0, so it's actually not going to move. Okay, this next point has a y-coordinate of negative 1. Negative 1 times 3 would be negative 3, so it's going to just drop down 2 units. And my third point over here has a y-coordinate of negative 2. Negative 2 times 3 would be negative 6, so 3, 4, 5, and negative 6. Okay, now before we draw our curve here for our final g of x function, we now need to translate those 3 points 2 units to the right. So 1, 2, 1, 2, and 1, and it's off my graph. We'll put it right over there. Okay, so I'm going to erase these first 3 points that we had here, and now we can draw our final curve. Now, once again, we are translating to the right. Okay, and so just like we think about our blue graph here, it approached the y-axis. Well, now our green is going to approach 2 axes over to the right from that y-axis, which would actually be this line right here of y equals 2. So I'm going to draw that in there. I'll make it a little dashed line. So we know that's basically our asymptote. We want to get close to that, but we do not want to cross it or intersect it. Okay, so I'm going to draw my curve here, try and get it through this last point right there. Okay, and so that's how we can perform some transformations on logarithmic functions.